head of at Henning Larsen, a leading firm in progressive architecture. Martha is a materials expert. She is working to establish a Danish building material passport and serves as a member of the Buildings as Material Bank's shareholder network. Martha has advised the Danish EPA on hazardous materials in building products and was awarded Building Green's Sustainable Element Person of the Year in 2019. She holds a master's in architecture from Washington University and a BA from Vassar College. Our third panelist, Kate Simonen, is the executive director of the Carbon Leadership Forum and professor and chair of the Department of Architecture at the University of Washington. Kate has connected her experience in building design with technical expertise in life cycle analysis, spurring collective action to bring embodied carbon to zero. Kate directs research at the Carbon Leadership Forum, leading collaborative initiatives such as the Embodied Carbon in Construction Calculator, the EC3 tool, and the Structural Engineers 2050 Challenge. And finally, we have Jennifer Wagner, who is president of CarbonCure Technologies, a high growth clean technology startup that is on a mission to reduce 500 million tons of carbon dioxide annually by 2030. The company has attracted world-class investors such as Amazon, Microsoft, Shopify, and Breakthrough Energy Ventures. And she has been recognized as Cleantech Group's 2020 North American Cleantech Company of the Year. Jennifer was recognized as one of the Business Insider's Clean Energy Rising Stars in 2020, Canada's Clean 50 Emerging Leaders in 2019, and a climate trailblazer at the 2018 Global Climate Action Summit. Quite the portfolio, I must say. We are thankful for these excellent panelists who have joined us, and now we'll move to brief topic studies, starting with Matt. Matt, the floor is yours.
Okay. Hi, everyone. Thank you so much for having me today. The first thing I want to briefly touch on is a project that I worked on around sustainable materials, partly being, based on the issues of carbon emissions, also the issue of toxicity, technical nutrients. And this project was called the Material Petting Zoo. It was selected by the Cooper Hewitt Smithsonian Museum for their triennial show. And basically the idea here was that we kind of took a fun approach to sustainability, and it was a carrot versus stick approach where we kind of entice people to want to lean in and learn about all the different material options that are out there. And this is for, things in the architecture space, interior design, industrial design, packaging, all sorts of industries. And so this is, one of the projects that's gotten a lot of recognition. And, we traveled around the world with this. We went to places like MIT and brought it to various corporations to, get people inspired and excited about all the potential opportunities there are for creating a circular economy. So some of the work that I'm doing now, I teach industrial design at California College of the Arts, and I'm very excited coming from the world of industrial design and also working in architecture and real estate development about the potential for things like generative design. And this is one of the collaborations that we have at California College of the Arts, where we're fortunate enough to work with corporate partners like Autodesk and use software like Fusion 360 to basically play around and come up with solutions for these technologies. And it's basically bringing the idea of AI and the knowledge base of all these different professions that are involved with creating products and buildings. So taking the engineering knowledge, taking design knowledge, taking manufacturing knowledge, and pushing what's possible in terms of materials. So being able to actually cost things out, to be able to price how much a certain design decision would impact the overall cost of the product or of the building, and looking at smart ways where basically having the computer tell us how can you use manufacturing technology in new innovative ways to allow products to last longer, allow them to be modular so that you can replace certain aspects that wear with time and keep the design fresh. And so, I'm very interested in all these kind of tools that are out there to facilitate the circular economy, to facilitate the triple bottom line, and to facilitate sustainability without a sacrifice to performance. Thank you.
Thank you, Matt. It's interesting to see the creative ways we can get people involved in the cause. Next, we will hear from Martha of Henning Larsen. Martha, whenever you're ready.
I'm all set. As you said so kindly in the introduction, I'm an architect and have been working in Copenhagen for over 20 years, working at Henning Larsen for quite a long time. Next slide, please. And our Henning Larsen's greatest contribution to the circular economy has been these 5 projects. Copenhagen has a very long tradition with brick architecture and has extraordinarily high quality bricks, so that it has been possible also through the development of a company in Denmark called Old Bricks, Gammel Mursten. This Claus Juhl Nielsen, the CEO of the company, has invented a machine that rinses bricks, and he can do this on a huge scale. So he's able to, one plant is able to rinse 50 tons of facade material in a day. And because of this means of scaling up and the huge quantities that his company is able to rinse, we were able to, within a period of 3 years, these 5 buildings came out, all in construction at about the same time. So this is an interesting indication of the quantity of the reused bricks in Denmark, and also the fact that it's quite feasible and very possible to scale up circularity with a very high quality product. For us, it's been extraordinarily important that when we talk circularity, that we're also at the same time looking at the carbon and looking at the savings. So that all of these projects are more a question of getting waste into the building as opposed to designing to get the waste out of the building. But on this particular phase of time with these 5 projects, we've saved around 1,000 tons of CO2 with these facades. Next slide, please. Another project that we have that's currently, they've just gone into the ground on this. This is a small cafe in Stockholm. And the take on this is much more future oriented, so that this has been developed with details so that it is lining up to prevent waste in the future. That is to say, these are details with design for disassembly in mind. I'm taking a look at the detail on the far right. The windows have been, the windows, as well as many other products in the interior of the space, are designed with visible screws so that the mechanical connections are accessible for exchanging the windows, which we expect to do within the 20-25 year life of the window products. So the other important piece of this project was to really keep an eye on the carbon, not in terms of waste, but in terms of designing with bio-based materials, so that we were working with the most positive or the best carbon profile that we could. Thank you.
Thank you, Martha. It's interesting that we can do so much, like change the makeup of the material as well as reuse old material to address these issues. We will now have Kate talk to us about embodied carbon. Kate, the stage is yours.
Great, thank you. So as mentioned, I head up the Carbon Leadership Forum, and the Carbon Leadership Forum's goal is to help eliminate embodied carbon in buildings and infrastructure, inspiring innovation and spurring change through collective action. So we're using life cycle assessment as both a method thinking and a method of analysis to look at the total life cycle impacts from origin to end of life, and ideally circularity or cradle to grave or cradle to cradle across the life of a building. So when we look at embodied carbon, we're looking at the emissions that take place in extracting raw materials, manufacturing them, building them, and then maintaining them over their life, and then looking at their end of life impacts. And so I think key to this is understanding where the majority of those emissions are. And if we look at greenhouse gas emissions for most building materials, 90% of those impacts are happening up front at the manufacturing stage. So that if we can come into a circular process in which we can cut off that stage of the life cycle, we can have a radical reduction in impacts of making buildings. Next slide. So I just wanted to bring up a couple of data points to put things in context. That demolition waste from commercial renovation is over 20% of the total construction and demolition waste stream. So if we look at commercial construction, we have just commercial construction, which is larger projects. So there's a lot of opportunities to engage in material reuse. We can have a significant impact. And then on the right is the results of a study in which we were looking at the embodied carbon impacts of tenant improvement and mechanical, electrical, and plumbing systems. And so if you look at the tenant improvement, that's refitting office spaces that happen relatively quickly. And if we look at, depending on the frequency and scale of the renovations, the impacts of the interior fit out and finishes can get up to the same order of magnitude of building a new building. So I think if we look at a circular perspective, first off, if we can reuse a building to begin with, that's the highest, best use of the building. And second off, there's a lot of material that's coming in and out of buildings, and a lot of opportunity then to think about how we might be able to turn that into a more effective circular economy.
Thank you, Kate, for shining the light on the importance of thinking about life cycle of buildings. It's absolutely true that there is so much that can be done with old materials, that old building stock that already exists. Finally, we now have Jennifer speaking to us about concrete and carbon removal. Please go ahead, Jennifer.
I'm hoping you can hear me. Please let me know if you can't. Great. Okay. So I've got a couple of slides here. I'll just walk you through what we're all about. So we're a Canadian company based on the East Coast, and we're one of the fastest growing companies in a space called carbon removal technologies. And what that means essentially is taking CO2 out of the air or out of smokestacks and actually doing something with it. So for us, we are recycling that CO2 to make concrete. And so the company, we're sort of squarely focused on our mission as a company, which is to reduce 500 million tons of CO2 annually by the year 2030, which is equivalent to taking about 100 million cars off the road. And so everything we do, all the decisions we make sort of leads to that North Star. And over the last decade, we've been scaling the company and our technology, which is a retrofit. So it's a bolt on to existing technologies. And Kate, I like your point about the best thing to do is to use the existing buildings. So we're similarly using existing infrastructure that's already in place in the concrete industry. So we're not suggesting that you abandon all the concrete plants and build new ones. We're working with existing concrete plants. Our technology is installed in about a day, and then they're able to recycle CO2 in their concrete. We've poured about 1 million trucks worth of concrete to job sites around the world. So the future is looking quite bright. I won't repeat some of these awards that we've received because it was part of the intro. Next slide, please. So I said we're based on the East Coast of Canada, a place called Nova Scotia. And the orange locations indicate where we're active today. So we have extensive operations across Canada and the US, also entering into South America, Europe, Australia, and Asia. And so for us, we're just scratching the surface. There's 300 plants now that are licensing our technology, but there's about 100,000 plants in the world. So we've got a long way to go. Next slide, please. And I wanted to sort of narrow in on one particular project that we're particularly proud of. So as we grow organically, we really think about what we can do to sort of amplify our scaling. So if you think about climate change, time is our enemy. So we really want to think about what can we do to scale up companies that reduce the carbon footprint of concrete. And so for us, there's sort of three main things that we think will help accelerate growth of technologies like ours. The first being government procurement that can have a massive impact on adoption of lower carbon practices in industry. Carbon offsets is another one where the flurry of net zero commitments by government and corporations have actually created some new capital into the space for technologies that reduce CO2. But also private sector specifications plays a really important role. And this is an example of this. So here we supplied a project, Amazon's HQ2 in Virginia. And this is a really good example where Thornton Tomasetti said, yes, I want to specify mineralized CO2 within the concrete on this job. And then we were able then to turn to the local concrete industry and say, okay, who would like to supply this? And then that opens the door to the conversation around, okay, well, maybe we should look at a lower carbon technology. And that can encourage them to come online because, as you can imagine, the concrete industry is quite conservative and sort of status quo is our biggest barrier, is that they've been doing things the same way for the last few decades. And unless one of their customers like Amazon is asking for it, they're not necessarily going to adopt a new technology. So for us, this particular project is under construction right now. It'll be completed in 2022, and it resulted in a reduction of about 1,100 tons of CO2. So just a great example of sort of that demand pull having an impact on the local concrete industry. So I think that's all I had to start off, but looking forward to the panel portion. Thank you.
Thank you, Jennifer. One wouldn't normally expect concrete to be a solution to our carbon problems. So I thank you for bringing this to us. And it's also amazing to hear that you're using existing infrastructure, because that is a piece that is usually very carbon intensive, setting up something new for new technologies. We will now go ahead and take some time for questions. We have about 5 minutes for each question. I will address specific questions to each panelist, and should time permit, we could get insights from other panelists on the topic as well. And as a reminder to the audience, please be sure to type your questions into the Q&A box in your control panel, and we'll get to those at the end. Martha, my first question is to you. What does a fully circular city look like in the future? And if you could expand on some of the challenges that exist today that keep us from achieving this, and how does this change in the short term versus the long term?
Okay, thank you. The radical changes of the future circular cities will not necessarily be visible on the surface. I don't think we can expect the shock of the new. If anything, it could be the lack of the new and the shiny that meets the eye. I certainly hope that the cities of the future will see many more retrofit projects, transformation projects, and renovations rather than new constructions from the ground up. On a material level, perhaps so-called new facade claddings may show more patina, will perhaps convey a visual story of their former use. However, the radical changes necessary for a functioning circularity in construction will primarily happen behind the scenes in the digital exchange. You could well have a building with recycled materials where it wouldn't be identifiable from the sidewalk. We now talk about establishing buildings as material banks, and the EU has completed a 3-year comprehensive study on circular construction called BAMP, Buildings as Material Banks, where the owner of the building actually owns a collection of resources that have an aggregated market value. This project mapped several of the immediate challenges and proposed solutions for many of these. For example, existing and new buildings need a much higher level of documentation in order to enable future circularity. Let me be very specific about this. This documentation has to start on a material level. on a product level, where it's essential to know the contents of the products all the way down to the chemical additives. And it's important to know what the product's next life is. Can it be directly reused? Can it be disassembled? What is the product waste profile for each component? What percentage is compostable? It's also very handy to know if there's a take-back agreement with the manufacturer. And even better, if this take-back agreement is registered digitally with the building owner and with the manufacturer. For building materials, we need to have this documentation, this transparency, similar to food labeling. So we know the contents and can be secure that a future use of the same product is a safe use. We don't necessarily know what the hazardous substances of the future will be. Asbestos was heralded as a miracle mineral when it was first introduced. So the first steps in the safe future circularity of new materials is to have digital documentation that's referred to as material passports or product declaration, with both content declaration and with information regarding the product's resource potential. There also needs to be a digitalized system for tracking and tracing, that this kind of valuable information follows the product and is accessible in, say, 20 or 50 years when the building is renovated or demolished. All firms are working with digital models of new construction. And as the building is constructed, material passes should be linked in digitally into these models. This would also be very valuable for the facility management phase of projects, in the maintenance phase. And the products themselves also need to have a system of Q codes or some kind of a tagging so that their data is also accessible on the physical product. The full realization of a building as a material bank comes to fruition when a building is well documented on a material level and the sum of its parts are digitalized, including the financial value of the building's resources. For existing buildings, we could also refer to them as donor buildings. A similar process of documentation and mapping of resources is necessary to ensure that future renovation or demolition can optimally utilize the resources of the buildings. So the immediate challenges are establishing a new digital documentation and tools, material passports, and digitalized systems for tracking and tracing. Part of this challenge includes convincing a conservative building product supply industry that being transparent has a value and it is in their interest. There are interesting new initiatives addressing this. For example, the Upcyclia.cloud in France or Medaster in the Netherlands. Denmark has strategies for mapping resources in existing building stock that is slated for demolition. And the US, of course, has the health product declaration with the content information, but is currently missing the circularity potential of the product. And you also asked about challenges for the future. I think the greatest one is that there simply is not enough raw materials that are suitable for reuse. We're already seeing this as a disappointing reality. Why aren't all aluminum facade panels produced with 100% recycled aluminum? It's because there's not enough and that you need the virgin aluminum in new production. I think that the quality of the materials is also a high concern. You know, we have a whole building phase from post-war until now where the quality of our materials is dubious, very hard to reuse products of lower quality. And I also think we're going to see debates regarding what and how much should be publicly accessible information in public registers and what level of information remains in a private owner's portfolio. A huge future challenge is, are those digital twins, those BIM models actually accessible in 5 years, let alone 20 to 50 or 60 years? So the flow of information that is so important, is so critical, needs to be also accessible long into the future.
Thank you, Martha. That's a lot to unpack and some great points. Would any of the other panelists want to talk about this? Maybe you can highlight some of the challenges that you see and or respond to Martha's ideas. Kate, would you like to go?
Well, I just want to, I think that Martha talked a lot about some of the challenges and the technical things, but she also started about how it doesn't it's not materially different. So I think there's just an interesting psychological shift that the circular city of the future will take. It matches to the sort of the aesthetic of repairing your clothes, or like so there is a visual difference to that in some ways, and some other ways not a difference.
Right, that makes sense. And perhaps moving towards slow consumption and just imbibing that that way of living for the future would be nice. Interesting. Matt and Jennifer, would you have any thoughts on this?
Yeah, I mean, one of the big things is cataloging the assets that we have, right? Cataloging these materials, that really resonates. And how do you convince or show the value or explain why, and allow other stakeholders to see the value in cataloging those things? And a lot of it comes down to those technical nutrients that we can, bring back and recycle, that are actually an asset of the building on a material level, I think is really important. And I would also say that we have some work to do to catch up here in the US. You guys are a little bit ahead of the curve, so I think we have a lot to learn from those kind of strategies also.
Right. Right. Jennifer, any last thoughts on this?
Yeah, I'll just say the point. I'm glad Martha brought up the transparency and the sort of the role that digital can play, and it's something that we spend a lot of time thinking about. And I guess I'll just say that just because from the perspective of sort of a material supplier, even though we aren't technically a material supplier, we're a supplier to a material supplier, is that I think the concrete industry at least understands that there are signs that these are going to be demanded, or at least you'll be given a preferential advantage if you have these documents in the short term. But the more that the architects and the designers and the building owners are asking for them, they'll listen. So I think they listen to their customers, and we need to continue to put pressure on the space to ensure that data is robust and available.
That is so true, Jennifer. Yeah.
So I guess the thing that's coming across is that how do you convince different stakeholders at different levels to really go with this idea? Great. I think I will move to my next question. My next question is to Kate. And and I guess we are moving into this, we're segueing into this perfectly, because my question is, how does one encourage designers to think about material recovery and designing out waste? And if possible, I would like you to address how does this contrast between the developed and the developing economies, because developing economies don't necessarily have robust recycling or end-of-life infrastructure. So how do you encourage designers to think about material recovery in both spaces, and what are the contrasts?
Great. Well, that I think we heard that was a perfect transition actually when Jennifer was talking about how the demand of the building owner and the ask of that is important, and I think it's also important to recognize that the actions of individuals also can be important. So there are choices that individual designers make about which material they use and how they put it together and how they detail it that aren't directly responding to the owner. So there's two scales. I think broadly speaking, we need collective understanding of the importance of these actions and a commitment to move towards them. So climate, it can be one key driver. Economics can be another driver. Our perspective at the Carbon Leadership Forum is that it is through that collective action that we will see a difference. And so we need to be working towards educating and empowering more people to take these actions and have the desire to take those actions. So it's, and so if climate is your driver, And if you're looking to understand and reduce the material impact of construction, that material recovery, designing out waste, is a key feature. I think your question around whether or not there's a difference between developed and developing economies is a really good one. And in fact, you see it even in the difference between Europe and the United States. So I think you might talk about it more as growing or stable places in which the built environment needs to grow in order to house and provide resources for people. So if we talk about a need to grow, then and a history of not using materials, because there's been a history of having less of those assets, it is definitely a different scenario. So there is a much stronger discussion around circularity in Europe than there is in North America. And likewise, you're going to see a different discussion in North America than you would in Africa. So it's a relationship of what the future will bring and how we can move towards that future. So I think you're wanting to think about the future use, the design for disassembly, but you're also having to really prioritize economy in a developing economy, because you're trying to get as far as you can with as little resources as you can. So that same basic principle is do more with less. It hits everywhere, but you really can't complain that that Indian steel production is almost all primary steel and North American has mostly recycled steel, when we have a whole bunch of leftover cars from the 1950s that we're recycling still. So that we have assets in recycled material because of our past consumption. So I think that's an interesting, tricky question. I think in terms of policy, there's a lot of opportunities for policy. There's both in policy and in the incentives. So how do you give priority to low carbon material solutions, material reuse, building reuse? There's lots of opportunities for incentivizing those from a local all the way to a federal scale. There are also opportunities to set targets and caps, so that California has a buy clean policy in which they're setting caps of the carbon footprint of material that they will purchase in the future. There's really there's a lot of opportunity in the material space for, I'll just add R&D and support for material development and R&D, so that in order to scale at the speed that we're needing to get action from climate, we pretty much need to use all of those tools to move forward.
Thank you, Kate. I do have a follow-up question. You touched upon economy and how that is a driving factor in different, I guess, in the developed world and the developing world. And we hear, like, for example, in the climate summit, in the Paris Agreement deal, we hear that developing economies want to, they don't want to take the brunt of reducing the carbon, because according to them, the Western nations have already spent their share of carbon, and they would like to have a little more leeway into, because a little more leeway to spend more, I guess, carbon, like to increase their carbon.
Yes, if there's a total carbon budget, arguably, developed countries have already spent our full budget. Or
right.
Perhaps, right? If you were going to equitably share that carbon budget.
Yeah. And with that in mind, because the economy becomes the stronger driving factor, and usually sustainability and economy are seen as decoupled ideas, so in that scenario, that's the reason why I asked, like, what happens in developing countries, because the idea is that growth would mean that you're not very sustainable. And then how do you encourage designers to think about these concepts?
Yeah, so I think it's interesting. There's the designers and the manufacturing. Those, I think, are the two different levers. And so in order to build if you're talking about just a square footage budget or a high quality building budget that's for equity, there is both of those things that are coming to play. So I do think you could be incentivizing investments in new material manufacturing. You have to invest in the infrastructure to make those material manufacturing happen. And if you do that in a carbon smart and material effective way, you have a lot of opportunities there. I think then that if we talk about designers and specifically, that is about what do we value in design, and where are our values, and how much is efficiency, material efficiency, and longevity and durability valued in design, and how does that fit into a cultural understanding of what people want? What do the owners want? What do the people want that want buildings? I mean, it's a really tricky question. My optimistic view is that we also have a shared understanding of the future that we want in 2050, that we've solved climate, and that collectively we're working towards that, and we want to do that so that people are happy and healthy and living well. So it's a tricky challenge, but I think it will be solved differently in different regions. That's clear.
Thank you, Kate. Unfortunately, we are running a little bit short on our Q&A time, so I'm going to move to Jennifer. Jennifer, would you want to expand on the role of concrete and other building materials in establishing a circular city, and also perhaps talking about the what role the different players across the value chain play in establishing the circular city?
Yeah, for sure. So for us, I mean, the reason why our company exists is essentially to respond to two key trends. The first being construction growth. So Bill Gates is famously quoted, some of you may have heard this, that we'll be building another New York City every single month for the next 40 years. And most of that construction will be with concrete. And so while that sort of usage is going up, there's also a greater understanding that we need to decarbonize every sector. But concrete and cement, cement is the glue that holds concrete together. And cement, just due to the chemistry of its production, represents about 8% of global emissions. And you can't have one without the other. So the cement and concrete industries recognize that they also need to decarbonize. And that's not easy to do. And so most don't understand the issue and think there may be simple fixes, but we're one of many solutions that's available today. So construction trends, decarbonization, that's kind of why we exist. And the role that different players in the value chain have in transitioning to this sort of more circular city approach is everyone has a responsibility. So whether you're a raw material supplier, or if you're an end user, if you're a builder, if you're a designer, there really is a role that everyone can play, and that does differ dramatically, of course. So for us, we have developed technology, so we're the innovator, but without a customer, our technology is completely useless. So we need to work with the concrete producers to install the technology in their plants so that they're able to consume the CO2. And then sort of downstream, we're working with the designers and the architects and the building owners to encourage the use of these low carbon building materials so that more concrete producers are looking for solutions. So I think that's a really important role that those two parties can play. I'm also pleased that Kate mentioned policy, because I think government does play a role as well. And there's sort of the carrot approach or the stick approach. I think we need both. And there's some really nice examples, especially in the US. Just for example, there's a piece of legislation in New York State, LECLA, which Kate will be familiar with, that's giving concrete producers sort of an advantage in their bids when they come to market with a lower carbon solution, and also requiring, to Martha's point, EPDs on projects. And so these are wonderful signals for government to take, to step up, to commit to transitioning to a more low carbon future, because the industry will be forced to respond. So it's a bit of a sort of a carrot and stick approach. But I think both are really important to getting to full circularity. Maybe I'll just pause there. I know we're short on time.
Thank you, Jennifer. I guess, Matt, with talking about different players across the value chain. So my question to you would be, how does one prioritize conflicting impacts when designing for circularity? For example, as an architect, I might be conflicted about the idea of water intensity versus carbon intensity, or just looking at costs of the projects using maybe recycled materials are not as cheap as virgin materials. So how does one prioritize conflicting impacts? And if you could point us to any tools or processes that help us with these trade-offs, that would be great.
Sure, yeah. So the first thing I would say, in terms of tools, there's a company that launched, I think they're still based in Boston, called Sustainable Minds. I think they launched back in 2007, right? And they're collecting LCA data on a whole variety of products. A lot of them are in the building material space. So that's a great resource. Another just inspirational resource for designers is the site that Janine Ben-Use created called Ask Nature, which is centered around biomimicry and thinking about ways that you can learn from nature, to create very efficient, sustainable closed loop systems. So those are two things I'd recommend. There's also a lot of design and architecture universities that have material libraries, right? So those are resources. There's a slew of material libraries around the world, and each one's going to have a different selection of products. And so, I encourage designers to go check those things out. And, in terms of like assessing the different types of impacts, things like the embodied energy, the toxicity of a product, being able to classify it as a technical nutrient that you could infinitely recycle. We need more materials like aluminum. We need materials that are like that have the performance and technical properties that we're looking for, that we can use in design, and that actually can get put back into the system and have value. And so there's a lot of, part of the work that I do as an industrial designer in consulting with various companies. Like, we've worked with a lot of different Fortune 500 businesses, and there are, one of the themes that keeps coming up today, right, is transparency and data, and how do we validate that these things are actually sustainable, and how do we track them, and how do we know that we're actually having an impact, right? And so it does get a little complicated. There are materials out there, certainly, and I could think of several examples where it sounds really good. It sounds like a bio-based, non-toxic, new polymer that is biodegradable, for example. And there's a company we worked with that was going to source this particular polymer from a large plastic supplier. And it's important to bring in people who have a technical background. So, I always try to work with scientists who have this LCA data, or pull data from different LCA databases. And we actually looked at the impact of this new progressive material that was, basically advertised as being super sustainable. And we did a life cycle analysis and put it side by side with the virgin material that the company was using. It actually did turn out that if they had just kept using the virgin material, it would have been better environmentally. And we had the data to back that up and validate that. And that actually steered a lot of decisions at that company going forward. And so it's really important to fact check, like, what kind of impact are we actually having, the impact that we want here? And the other side of it is that some of this data is hard to get because manufacturers aren't tracking it, right? We've heard a lot today that we need more transparency. We need material suppliers, actually the companies that are making the materials that go into the building, materials that an architect or developer could source to use in their projects. Some of the data is just not necessarily there. And so we need more transparency on that. I totally agree. I think somebody was mentioning earlier that the government, is a part of that, like having actual regulation where, the disclosures are required, I think is important. and also having companies see the value that this is good for business too, right? And also that they need to kind of start this early and know what their issues are and know what they're dealing with to actually be able to address it. And so that happens through, tracking what's actually going on, like what are our environmental impacts. And there are some companies that are doing LCA analysis on their product, and they are like very technically looking at the toxicity. But as mentioned earlier, they're very busy with production, right? And so if they don't see the direct need or desire from their customers to actually supply that data or have that conversation, and if they don't know that it's super important, they may just continue focusing on doing things the way that they're doing them. So I think these these discussions where designers and developers are driving the transparency and saying, hey, I need this data because we need to validate it. We need to talk about this in our project, and we want to holistically think about how all the pieces of this building go together. And the other thing is, for example, right, like design plays a really big role. So it's not just the material, right? You can't just say, I'm going to source a, super insulating, super high R value, product. If the building envelope isn't sealed, right? For example, right, you don't do a blower door test or something like that, then you've kind of negated the sourcing of that material. So how you handle the material and how you deal with the materials that you source and how you put them together, whether they're designed for disassembly, also have a very big impact environmentally. And in terms of the ability to actually fulfill on the intention of designing something for the circular economy.
Thank you, Matt. So I'm getting that more publicly available data going forward. I think we got that across. All our panelists mentioned that, and I guess we'll also now take some questions from the audience. Martha, this first question is directed towards you. Could you share more about the long-term longevity and maintenance of buildings when using recycled bricks? And when a building made of recycled material reaches its lifespan, what is the continuous recyclability of that material? Like how many times can we recycle it? Yeah, I guess that's the question.
I'll take the second question first, and that is, it depends completely on what the material is and where it is in the building. It's very dependent on whether it's recycled concrete that's in the foundations or whether it's something that has much more exposure. And in terms of the bricks, they're very high quality bricks. They've received the same CE quality stamp that an equivalent quality stamp that a new brick in production receives today. They have been through testing processes for compression and for water, how much water they take in, and all of these technical aspects. In terms of their life, I think that I don't know if there's a number that the company puts on this, but I think that what I've heard is that it's just a very long brick life, similar to the new bricks, which the new bricks are between 60 and 100 years. I think that we have often discussed, okay, if we just use the right mortars, the old lime mortars, then our buildings could then be recycled again if we take the facades down. I'm a little bit in doubt about that. I think going through the rinsing machine twice, they would be quite rounded. I think they'd probably be better suited for something that's not a facade, but may have another life in them, but it may not be a facade.
Got it. So potentially looking into other uses as well. And those need to be identified beforehand.
A lot of them are already, because in this process of rinsing, there is, of course, not every brick comes out as a full brick that's usable for the facade. So they have other streams for their waste. They use it, sell it to the green roofing industry that uses brick in the basis for the sedum plants that grow. Can be used in road fill and in etc. But those are, of course, downcycling uses.
Great, thank you, Martha. Kate, my next question, the next question from the audience is actually, how beneficial would steady, dependable, high quality flow of used materials, um, basically a consistent supply chain, be for architects, builders, and owners to uh, to think about embodied carbon and continue this work?
So if you're talking about material reuse, a consistent
Yeah, like
supply
what
chain
a
is,
consistent, dependable supply chain, is that the key to reuse of materials?
yes, right? I can't say that I'm going to clad 5 buildings with brick unless there's a supply of brick that I can depend on and a system in place to wash them, store them. I'm guessing Martha would say that there's a yard and they know they have a year's worth of backlog and they've got a plan, and they probably so there's 2 parts of that, or maybe there's more than 2 parts. You have, when somebody demolishes something, they have to have a place to put it, that somebody and then the person who is going to store that thing has to know that there's somebody will eventually take it, and then when the person who eventually takes it, they have to know that it will be the thing that they want. So even like reuse of carpet. The carpet, there's a whole bunch of carpet tile that gets unused because people no longer like what it looks like, but it works just fine for carpet. But I can't plan ahead for 18 months from now that whether or not I'm going to like the carpet that's in the shop at that time. So this is, that's a tricky challenge. There are policies in place that can help support that. So for example, in Portland, there's a deconstruction ordinance for older homes that then requires these homes to be deconstructed, building up a local workforce that knows how to take things apart carefully and then supports the storage of them, with the aim that there would be resources from old growth timber that was used to frame the homes to other fixtures and fittings. So yes, the answer is that's probably the trickiest challenge. And as Martha was noted, if you take it apart, but you don't know what's in it, it's hard to know what to do with it. I can't be confirmed that it doesn't have asbestos if I don't have a material bank or record of what it actually was.
So I guess some institutional infrastructure is important to have in place. I will now move to our most upvoted question, and I think we have 2 minutes to address that. How do you recover old bricks or materials effectively from buildings which were designed decades ago, but without disassembly in mind? And I open it up to anybody on the panel.
Well, I think, it depends on how many buildings are out there, right? If there's a drive to create some sort of machine or mechanism to reclaim those, and there's a financial opportunity, people will, tend to want to do that. I worked on doing an adaptive reuse project, developed a 13,000 square foot building. It was a former factory on the East Coast that was at one point owned by Warren Buffett, right? And so a lot of those, every building is different, right? And so a lot of times you end up doing very custom things for a particular project. If there's a supply of something, companies are going to be very incentivized to essentially figure out how to reclaim that material if they can do it in an efficient way. So, I mean, I think that's one idea, that's one kind of component about maybe reclaiming resources that are out there. And on the industrial design side, right, like we throw away however many precious metals in terms of all the electronics products that basically go into landfill, right? And so at a certain point, it's going to be a big business to figure out how to reclaim that, and we'll figure out ways to make it optimized and efficient so that it's profitable to mine the landfills essentially and reclaim those materials.
Great, thank you. Thank you all. This was an enlightening session and we're at the end of it. For the audience, I would like to reiterate that we have another exciting panel on designing out waste in consumer electronics. It's on the 20th. The link should be posted in the chat now. And do sign up. And I'm extremely grateful to our panelists for joining us and talking about this important work. I hope the audience learned just as much as I did. and is inspired to take this work forward in their own way. Please be on the lookout for additional resources on our website, circular@harvard.org. And I would like to thank my team, Ryan, Kathy, Will, Janina, and Sandra, and Kritika for bringing this panel to you. I'm Akriti. We're signing off now on behalf of our Harvard Circular Economy Symposium. Thank you for joining us, and we'll see you on Tuesday for our next panel.
Thank you
Thank
so
you.
much.
Thank you.
Thank you very much.
Bye-bye.